One of the most common guest suggestions that you, dear listeners, make is inviting Paul Bürkner on the show. Why? Because he's a member of the STAN development team and he created BRMS, a popular R package to make and sample from Bayesian regression models using STAN. And as I like you, I did invite Paul on the show. And, well, that was a good call. We had an amazing conversation spanning so many topics that I can't list them all here. I asked him why he created BRMS, in which fields it's mostly used, what its weaknesses are, and which improvements to the package he's currently working on. But that's not it. Paul also gave his advice to people realizing that Bayesian methods would be useful to their research, but who fear facing challenges from advisors or reviewers. Besides being a Bayesian rockstar, Paul is a statistician working as an independent junior research group leader at the Cluster of Excellence SimTech at the University of Stuttgart, Germany. Previously, he has studied psychology and mathematics at the universities of Münster and Hagen and did his PhD in Münster about optimal design and Bayesian data analysis. And he also worked as a postdoctoral researcher at the Department of Computer Science at Aalto University, Finland. So, of course, I asked him about the software-assisted Bayesian workflow that he's currently working on with Aki Vetari, which led us to no less than the future of probabilistic programming languages. This is the Future of Learning Bayesian Statistics, episode 35, recording November 5, 2020. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.com. That's learnbayesstats.com. Do you want to support the podcast and unlock exclusive Bayesian swag at the same time? Then you can visit my Patreon page at patreon.com/learnbayesstats. Starting at €3, you can get various benefits like the private LBS Slack channel, early access to special episodes, selecting questions for episodes, or even coming on the show. You'll get more details at patreon.com/learnbayesstats. Thanks a lot, folks. I'm very grateful for any support you can bring me.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? Is someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen. Maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men, dropping placebo-controlled science like I'm Richard Feynman?
Hello, my favorite Bayesians. I'm proud to say that this episode of the Learning Bayesian Statistics podcast is brought to you by Tidelift. Tidelift is making open source work better for everyone, users, companies, and car developers. Make sure to listen to their dedicated segment during the show to discover how they help open source software. And by the way, if your company wants to support this podcast, raise its brand awareness, or put its job ads in front of the right people, just get in touch with me and we'll see what we can do together. And I'm sure you know that another way to support and improve the show is to subscribe to the Patreon over at patreon.com/learnbayesstats. Talking about it, I'd like to thank my brand new supporters, especially those in the full posterity or higher. So thank you very much, Jonathan Sedar, Henry Wallen, and Clive Edelstein. Your contribution makes a big difference. I hope you folks are all doing good. And now let's listen to my conversation with Paul Bürkner. Paul Bürkner, welcome to Learning Bayesian Statistics.
Hey, I'm glad to be here. Thanks for inviting me.
I'm very happy to get you on the show, not only because I love your work, but also because several listeners asked me to get you on the show.
Oh, I am honored.
Yeah. So my first question, of course, will be, Paul, how does it feel to be a rock star?
I don't feel like one, to be honest. There may be places where people know me, and there have been situations where people have been happy to see me about that. But there are also lots of people who don't recognize me. Then I talk about BRMS and I stand there they don't know. So I don't really feel like one. Like the few situations where people recognize me in conferences or so, it feels quite good to be honest.
Yeah. I think my yardstick is, did you already get a free beer in a bar because someone recognized you?
No, a lot of people have promised me to give me free beer in bars when we next time see each other, but then 2020 kicked in and like nothing.
Yeah. Well, that's actually a good trick. If we meet within 2 weeks, Paul, I'm paying you all the beers you want.
Yeah. Be careful. I'm in Paris soon. I'm just joking.
Yeah, but we're under lockdown, so I can't leave my apartment. I mean...
Oh, okay. I understand. So I'm going to be in Paris, but I'm going to like shout from the streets.
Exactly. But I have no beer. I mean, so...
Okay. Well, no beer for me then.
Yeah, we're stuck. The first time it happens, you tell me, and then you come back on the show.
Yes.
Okay. Let's start by your background. Actually, I do that with all the guests. And yours is interesting because you started by psychology and mathematics. Actually, I think it's quite similar to Lauren Kennedy's background. But yeah, we'll see. And now you mostly work on statistical methods. So how come and what's your story, basically?
So basically, when I was thinking after school kind of what to study, I kind of had multiple things in mind. And I thought psychology could be one of good options because there's such a diverse amount of things you can do with that. And I didn't really know. And so I kind of chose that. And also my mom is a psychologist also and doing research. So I had kind of some connections to that. So I thought that might be a good idea. And I liked it, specifically like statistics. But I kind of felt that the statistics they taught in psychology at the start were not enough. The professor could have told us more, but like it wasn't part of psychology. And so I decided to also additionally study math to get into more of the details of statistics after my second semester in psychology. And after that point, I kind of continued math and psychology in parallel. So that's kind of the story, how I ended up with both of them.
Yeah, that's interesting because you knew that you liked both kind of from the start from your undergrad studies, right?
Yes. Yeah, so basically I started math 1 year later than psychology because kind of I wanted to learn more and psychology wasn't kind of enough. But yes, I liked both of them and I continued both of them kind of happily. But basically statistics is where they meet. Interestingly, I didn't learn a lot about statistics from my math studies. So I learned a lot of math, which helped me now, but statistics-wise, it hasn't been that great actually.
No, I understand. I think it's the same for me. Like I did a lot of linear algebra, etc. It helps you like for algorithms and so on, but it's not statistics. Yeah, actually, it's interesting to see that like now a bunch of guests on the show have had the same path in the sense that they start with psychology and then they end up doing more mathematical stuff. And then at the intersection of both statistics, like Chunpeng Lao, you, Thomas Vicky, Lauren Kennedy, and I'm sure I'm forgetting some others. So it made me learn that psychology is actually quite computational and quantitative. My prior wouldn't have been that, you know.
That's true. And it also, I think it depends on the university, it depends on the country, and it depends on who specific is teaching there. It's very quantitative, but the question is how mathematical and statistical it is. It strongly varies. I think so in the cognitive science, and we have lots of also like complex mathematical models. There are lots of other areas where they're kind of not really going beyond analysis of variance kind of models. So the complexity of the statistical analysis varies a lot, but most of them, at least in Germany, kind of do quantitative research.
Yeah. Okay. Interesting. Yeah, and actually what they're doing nowadays, because I think you just got a new position, right?
Yeah, so I got a new position in Stuttgart at the Cluster of Excellence for Simulation Technology. It's called an Independent Junior Research Group Leader. So it's kind of paid like an assistant professor, but I don't have to do any teaching, and I'm quite grateful for not having to do any teaching right now because kind of online teaching is difficult. So what I'm doing these days is basically continue working on methods for what we call kind of the Bayesian workflow for data analysis. I mean, there are lots of people working on that, but like I'm one of them. So I'm hoping to have 2 PhD students working on 2 different projects start of next year, which are basically then specific parts of that Bayesian workflow. And so one thing that I want to focus on more is kind of specifying prior distributions, because when we start talking about Bayes and introduce people to Bayes, we talk about the prior a lot. And then when it comes to applied settings, we say, it's really difficult to set a prior. We go with the default one somewhere in some package.
Yeah.
Like to keep it simple. And perhaps it's not the best strategy. And I'm trying to improve actually using priors in practice and make it easier for people to do that. And that's kind of the stuff I'll focus on more in the next couple of years, I guess.
That is super interesting research. We'll talk more about this project at the end of the show, but let's go back to this question because otherwise I'm feeling that we're going to get sucked in by this topic. before that, I'd like to ask you, that's something I often ask the guest, because now you do less psychology, right? You're more on the methods side of things. But I'm wondering then how Bayesian is the field of psychology?
So it's becoming more Bayesian. And I think Stan and BRMS have important impact on that.
Mm-hmm.
I think it was Bob Carpenter from the Stan team who was basically saying that kind of BRMS single-handedly transformed psychology to use more Stan. Not really quoting him, but I think that was the meaning, and I hope I remember that correctly. So I think this is one aspect, so it's becoming more Bayesian, and then there's other aspects where we have lots of cognitive psychologists working with Bayes factors, and they have been pushing Bayes factors quite a lot into psychology. And so there are different kind of streams of research and people working on Bayesian methods that work in psychology or are adjacent to psychology. So we're getting them more and more in some sense.
Yeah, great to hear. And yeah, definitely, I think indeed that BRMS seems to have had this big impact on the field. And we're actually going to talk later about that. But first, I'd like you to have some teaching duties then after the quarantine, because then you will be able to introduce new students and new people to Bayesian methods. So yes. I hope you will get to do that soon.
I will, and I can also choose the kind of teaching I want to do in Stuttgart. So I can choose, I want to teach Bayesian statistics.
Yeah, definitely. I mean, of course. Are you going to use BRMS or not? I don't know. What's your take on this?
I will probably use it kind of a mix of Statistical Rethinking, the book of Richard, and then the translation of Solomon Courts to BRMS code. I think this is the kind of stuff I would build a course on.
Nice. So if listeners already want to enlist, I direct them to you.
I hope I didn't promise enough, but we'll see how it goes.
It's too late, Paul. It's on record now.
Okay, so I know. Unfortunately, I can still stop Audacity. But I already know it won't help, so yeah.
Actually, I'm curious how you personally first got introduced to Bayesian methods.
So I think that we had a meeting, an informal meeting of our work group, because we actually a Christmas party, where Christmas party means sitting around in our professor's room and having some cookies and wine, which was nice. So after my second semester in psychology, and there were two people like talking about some Bayes stuff, and I was interested in that because I didn't really know it. And people recommended to me the book of John Krushke, Doing Bayesian Data Analysis, like the book with the docs.
Yeah.
At least initially it had docs on it. And so I bought that, and basically during the summer break, I read most of the material there. So this was the first introduction to Bayes, and then I didn't really follow up on that during the next couple of years because I didn't really have time, and only started thinking about that more, I think, when I was starting my PhD or doing my PhD. So I was introduced, then didn't work on it for a few years, and then kind of came across it again during my PhD, where I then actually like deepened my research interest into that area.
I don't think we can qualify you as a late bloomer. Lots of people learn Bayesian statistics quite late, actually. But
yeah, I don't know. Perhaps not.
Yeah, I don't think so. Basically, Bayesian statistics are not really, at least for now, really well taught in undergrad and so on. So
no, they're not. But I'm planning to change that wherever I'm going to teach.
Well, that's good. That's good.
To the excitement of some professors with whom I discussed that, for instance, when I'm going to talk to people in psychology, saying sort of I would like to teach Bayes already in undergrads, and they're like, "Oh, isn't that too hard?" I'm like, "No, we're going to do it anyway." Not sure that like how that comes across, but yeah, we'll get there.
Definitely. Well, I completely support this effort. So if you need some hand, I'm here.
I'm
with you.
Yes.
I'm with you in that.
Thank you.
Definitely support this. We can do like a French-German relationship on the Bayes stats side, you know.
That would be amazing. Yes.
Yeah. Indeed. Also, I want to ask you how you came to R and Stan, actually. Can you walk us through your programming journey, basically?
So we have in undergrad, in the first 2 semesters in psychology, we have started with R. So I got introduced to R by then, and basically all the kind of programming I did, for instance, for my bachelor's thesis in psychology, which was a simulation study, I did in R and kind of then learned by then. I still have the code from those studies, and I can't look at it because the code is like not quite good looking from my perspective now. So this is where I basically got introduced to R. If we speak of like general purpose programming languages, I'm quite monolingual in R. I have some Python, some C++, but it's mostly R because I've done everything in that. And Stan was, I think, I was working on tutorial paper for ordinal models, which actually happened to come out in 2019, but I was starting to do that during my PhD. And then was specifying those models in JAX, which is another probabilistic programming language, looking like bugs. And I had some complex ordinal multi-level models, and they just didn't fit at all. So kind of the chains got stuck in different areas and nothing seemed to help. And there was a colleague suggesting to use Stan, which I think was in start of 2015 or so. By then, Stan, like RStan, wasn't even on Cron, so everything was just on GitHub. And I would try that out, and it just worked like that. And basically, this kind of Stan code I built back then was actually the start for BRMS in a very specific context.
Okay, so you started using Stan before working on BRMS.
Yeah, basically simultaneously, in the sense that it's kind of the code I was writing back then became the initial core of BRMS.
Yeah.
And I had no idea of package development or software development more generally, so it was quite ad hoc, the first version of BRMS that then happened to have the Stan code in it.
Yeah, I see. Is it at the same time that you joined the Stan team, or was it after BRMS?
No, I think I officially joined the Stan team 2018. I may be wrong. It may be 2018, which was basically because BRMS was becoming so huge and a lot of people were using Stan through BRMS that I think it was Jonah and Aki, I guess, who kind of suggested to kind of invite me to become part of the Stan team, and BRMS then also become part of the Stan packages. So I was developing BRMS and the stuff I did in Stan independently until like 2018, I think.
Okay, so actually let's dive in a bit into BRMS now, which is the package you created and still maintain. Can you tell people what is it? Also, why did you end up creating it?
So BRMS has a horrible name, but it stands for Bayesian regression models using Stan. And it's basically trying to do that, fitting potentially very complex regression models in a Bayesian framework, like using Stan at the backend. And at the core of BRMS, you can fit lots of multi-level models with a lot of different response distributions, not just the usual ones like normal, Poisson, binomial, but a lot of complex ones, for instance. Exponentially modified Gaussian, you can fit a lot of skewed distributions, ordinal distributions for time-to-event data, for instance, Weibull, or kind of a Bayesian version of the Cox proportional hazards model. So there's lots of flexibility there, and you have lots of different terms, so you are not stuck to some linear multi-level formula. You can add splines, you can add GPs, you can model missing data, for example, you can model measurement error. And you can even fully specify completely nonlinear models with different nonlinear parameters kind of related to each other, each with their own linear predictor terms. So it's kind of one of the most sophisticated, I think, regression frameworks we have at the moment in R using our formula syntax. So the second question was kind of how I came to it, which is kind of accidentally explained already when I was starting this tutorial on ordinal models, and I was kind of writing Stan code for that and put that into a small package. And when I was realizing this worked quite well for ordinal models, I thought, okay, I did it for a complicated kind of model. Why not add some more easier models like normal distribution, Poisson distribution? So I kind of added that as well. And then I stopped completely working on this ordinal tutorial for ordinal regression and completely focused on developing BRMS more and more over multiple years in some sense. But I think the first version of BRMS hit Cron in May 2015.
Oh yeah, so it's been quite a while now.
It's been quite a while. It's becoming an old boy, yes.
Yeah, that's nice. Yeah, so, and the particularity, as you were saying, is that it provides people with a framework on top of Stan to do these kind of complicated regressions. And so the nice thing, I guess, for people who are used to Stan is that they can use the classic regression formula syntax, right?
Exactly. That's one of the advantages. So the kind of writing the Stan code is much faster because BRMS does it automatically. You have the simpler syntax and all the post-processing is ready already. That is, you don't have to compute your own log likelihood values, your own posterior predictions. All of these things have methods in BRMS which you can automatically call also with new data and lots of other post-processing options. So it automates a lot of things people want or need to do anyway for their Bayesian models.
Okay. Yeah, I see. And so you can, on top of that, add hyperpriors for hierarchical models. You can add non-parametric terms, as you said. I'm guessing you added these kind of new features gradually in the 5 years now.
I did. Yeah, I did that, and I mostly did it mindlessly initially because I had no idea. So I had to refactor BRMS majorly at least 2 or 3 times because I got stuck into a certain direction and realized it was going really badly. So I kind of had to remove a lot of stuff or change it completely and then working in another direction because I had back then no idea how I wanted to develop it. So it was a long journey with lots of learning opportunities from my side.
Yeah, you can't really anticipate all the kind of models that people will want to use and so on.
That's
so
true.
is it like users who requested the kind of models, or did you like end up saying, oh yeah, I should add that, and you had like your to-do list that you were checking, or is it more like user requested?
In lots of ways, it was user requested. In a way, I was my most annoying user myself that I wanted to do stuff, which then I couldn't, so I built it into BRMS. But like a lot of things is user requested nowadays. Sometimes I've started like turning down also some user requests because there's directions in which I don't want to develop BRMS based on like some experiences I made that some things should better not be added. But yes, it has been mostly users, and nowadays kind of there's this BRMS issue list which has about 80 issues, most of which are feature requests even by myself or by someone else, and a lot of which may be eventually implemented in BRMS, but perhaps unlikely by me, depending on how much time I will have to develop it further.
Yeah. And also, I'm guessing that sometimes you must not know what kind of model it would require. I mean, sometimes I'm guessing that people have very specialized requests for complicated models. And
True.
That's actually good for you because you would have to go into this kind of model and learn it yourself. But well, sometimes you don't have time to do that.
Yeah, but you have a good point, basically, that a lot of statistics I've learned was because people are asking me, can you add this feature? And I had literally no idea about what model they're talking about.
Yeah.
And then I was diving into it and looking at it. For instance, the first time I implemented kind of autoregressive moving average models, like some ARMA models for time series, I did it wrong in a way that my first AR terms were just plainly wrong because I had no idea how to do it correctly. And I learned from that, and now they're hopefully reasonable. And there have been lots of situations where I had no idea, had to look it up, and then eventually understood what was happening to be able to implement it and actually get it to work. And now can recommend people actually what to do with it. So that's been nice.
Yeah, that's super nice. That has also been my experience on open source. Like sometimes you just gotta say, okay, I'm gonna work on this issue or this pull request and we'll figure it out on the fly, and that's how you learn. And that's actually like super pleasant also to do that. It's like a big challenge, but then at the end you're like, I'm really glad I did that. Also, I'm curious how many contributors you have now on BRMS, because this is quite a big package and with a big user base. So I'm guessing that being alone on this is quite hard to maintain everything. So did you manage to get some help from outside people?
I must admit I didn't really look out for people. So nowadays, in the description file of BRMS, there are both Jonah Gabri and Sebastian Weber mentioned as contributors because Jonah and I have been talking so much about these things. Jonah is also part of the Stand team, for those who don't know, and has been working on Asta and ARM and a lot of other packages. And he has helped me with so much that he has deserved contributor multiple years ago, but I forgot about it. And Sebastian Weber has helped me with in-chain parallelization in BRMS. And so that's basically that. And they have quite a few people basically fixing documentation, that kind of stuff. But it has been like code-wise 99% probably it has been me. And I think it makes sense that eventually there are other people like really doing coding in that regard that also have to work with me on my baby. And this is going to be hard for them. So I'll need to come a little bit emotionally more distant to BRMS before it's becoming easier for me to let other people work on it, I guess.
Yeah. But that's a good problem to have. I mean, it's good that people are willing to contribute to the package and help you maintain that and make it even better.
Yes, and the way people have contributed was like not only with kind of feature requests, but lots of bug reports, reproducible examples, and lots of discussion. So there have been probably hundreds of people who have helped me basically improving BRMS. So it's just basically not really reflected in the amount of coding been done, but in all the surroundings, writing blog posts about that, writing papers about that.
Yeah, this is great. This is really awesome. And actually, I'm curious, how did you manage to fit that work into your PhD and then, well, your postdoc? I think you did that at Aalto with Aki. So yes. I'm guessing that he's very tuned into this kind of work. But I mean, in a classical PhD program, I would anticipate some problems, with the classical academic framework where the output of a PhD is a paper and is not really a package, no matter how well developed it is, how widespread used it is. I mean, so how did you fit that into your PhD work,
Yeah, that's a very good question. So basically my PhD was relatively open. So I basically agreed to do a PhD with my professor there. And then after I was there, we discussed some ideas for papers. So the first one was actually about some optimal experimental design for some frequentist test. Quite mathematical statistics in some sense. And then I was like thinking of this ordinal stuff, and then suddenly became like Bayesian and writing BRMS. And in a way, BRMS contributed one of the papers to my PhD in the form of the Journal of Statistical Software paper. I think it worked because my professor just gave me a lot of freedom to let me do it, because I was still like working with him on optimal design stuff, and like 2 of the 3 papers in my PhD were about optimal design. And yeah, so I just continued working on BRMS, and it has helped me through a lot of collaborations and other papers that I've got from there to actually a lot of publications are related to or because of BRMS. So in some sense, it has actually paid off in terms of publications and academic success, but it wasn't clear from the start because it wasn't clear at all that it would have been so successful. I think I was quite lucky with that.
Yeah, I think it's definitely a risk. I'm really glad that this kind of stuff can happen. I mean, that's so good that you had a PhD supervisor that was open to this kind of work, and then you got to work with Aki. It's really great.
Basically, Aki knew me from BRMS, and he hired me because he knew my work there. So And interestingly, I think after BRMS was already developed a little bit for 1 or 2 years and was becoming quite successful, I actually looked up for some like other packages related to that, basically trying to use Stan at the back end and making some R or related package at the front end. There happened to be a lot of kind of dead-ish packages being developed. Some of them have been abandoned before I already started doing BRMS. So if I had seen them back then, I would have not considered working on BRMS because other people already did and had stopped. So it was good that I was naive and just continued working.
Yeah, exactly. That also reminds me of some literature I read, because I like social science literature and especially like behavioral science, stuff like that. And like I read, I don't know, a long time ago, something like it's actually good that our brain tends to be overconfident, because otherwise most people wouldn't try to build any company, or like, build anything that's risky, try to make it into cinema or, stuff like that. So, and like, trying to build a package that's successful is like a really risky enterprise if you look at all the packages that tried to make it and couldn't. So that's quite good. Because that was also the sense of my question. I'm guessing that maybe some of these packages in there that didn't make it, it was because like incentives were not aligned with these people's PhDs or stuff like that,
I would think so, yes.
Yeah. That's really something I'm sensitive to, as you can hear. Maybe another question for you that's more statistical, and I want to do a show about these methods, but maybe as a teaser for listeners, because I've never spoken really about that. You talked about splines before. You mentioned splines.
Yes.
And that people can use splines, for instance, with BRMS. So maybe give us the elevator pitch for splines. Like, what are they and why are they useful?
So when you have the intuition that the relationship of 2 variables is not necessarily linear, but something nonlinear in some sense, but you don't have any idea of how that might look, right? So that you can't just specify some structured curve right away, then you just throw a spline at the data, and the spline is going to figure out the nonlinear relationship in some sense. The splines that are working in BRMS are kind of set up in a way that they are not too dangerous in use, because if you just fit a spline and it's very flexible, it's very likely to be too flexible that it kind of just fits on noise, because it can fit almost anything. And so in BRMS, the splines that we're using are penalized splines using price in the Bayesian setting, so that they're trying to not overfit too much. So that's the good thing of splines, so you can fit nonlinear relationships. Kind of the bad thing is that the parameters of splines are not really interpretable. So you mostly understand splines when you look at the visualizations, when you look at the predictions of those, in which case they're really useful. Or if you just want to control for a variable in some sense that is supposed to have a nonlinear effect, then you fit a spline on it and just hope you have corrected in whatever way. Yeah, so that has been a long elevator pitch.
No, that's good. I love that. I mean, maybe we were in a big building, so
yes,
I don't know.
So for that.
exactly. I often see splines used, for instance, for time series data or stuff like that.
Yeah. It's interesting for time series data, when we're trying to make predictions into the future, that's usually one of the tasks in time series, then splines are also a little bit difficult because they are kind of theoretical, and depending on how you implement it, they are not necessarily predicting well beyond the space where we have data, so they're not necessarily extrapolating well. It's also a little bit dangerous, at least when one aims to do kind of predicting the future using splines. Yeah, so there's some extra caution required, basically, that I also learned while trying to do that and then wondering what was happening.
Mm-hmm. Yeah. There's definitely material for a whole episode about that here, so I'm gonna definitely keep that in mind. Also, like the relationship with Gaussian processes, because it seems to have the same characteristics and main points and strengths and maybe weaknesses, so I'm curious about when to choose one instead of the other.
Every time Aki and I talk about splines and Gaussian processes, he tells me something new about their relations and about Gaussian processes. So.
Yeah. No, that's definitely when I do a show about that. And it's also, I want to use more splines in my own modeling. So that's something I'm really interested in. But let's not dive into this whole, because otherwise we're going to end up there. Actually, when I refocus again on BRMS, and first a short question, but I think that will be useful for listeners, is in which fields do you see BRMS mostly used? And are there most appropriate use cases of BRMS in your opinion?
So I don't know for sure. I know that they're used in a lot of psychology, cognitive science areas. I think BRMS is used quite a lot in biology because it has some features that are specifically interesting to biology. For instance, when we are modeling phylogenetic structures or inheritance structures of animals, and this kind of stuff that one can do with BRMS. I'm not sure what the most appropriate use cases are. I think where BRMS really shines is when you have some nicely structured multi-level data and you have lots of complexity, but most of which can be expressed in some additive structure with potentially linear, non-linear terms, multi-level terms. I think this is the kind of stuff that BRMS shines. It doesn't really shine super well if you have very custom, highly complex, let's say, differential equation model. You can put that into BRMS. People have done that, but it's then a lot of extra work. It's probably easier to just go to Stan directly. So whenever you have these kind of additive predictor structures, I think it's the best use cases. I have only a limited idea of a lot of quantitative scientific fields to actually know how well those models apply there. For instance, in engineering or something, I would assume a lot of people are more working with differential equation models.
Yeah.
Which is just a very different story. That is also, it's possible to fit it in Stan, but it's also difficult because the estimation tends to be quite slow.
Yeah. ODs, PDs, etc. This is still clearly at the frontier of these kind of statistics.
It is, yes, definitely.
Yeah. Definitely super interesting stuff happening there, but still very much at the frontier.
Let me show you how to be a good Bayesian.
Hey folks, as I told you at the beginning, this episode is brought to you by Tidelift, and I'm really proud of it. In a nutshell, Tidelift helps organizations effectively manage the open source behind modern applications, including the tools to create customizable catalogs of non-good, proactively maintained open source packages backed by Tidelift and its open source maintainer partners. For instance, PyMC3, that I'm sure you all love, is part of the Tidelift subscription. So if you are using PyMC3 in your organization, you can seamlessly and efficiently integrate it into your organization's software policies and workflows. So it's nice, right? So go ahead and check out tidelift.com to learn more. Actually, I know that BRMS is used in the linguistics and speech science field.
Oh, yes.
Yeah, because I am actually a listener of the podcast, Alison Hilger, or Hilger. Sorry, Alison, if I mispronounced your name. And she's actually also a patron of the podcast. So thanks a lot for your support, Alison. And well, she told me that something you often do, Paul, is publishing tutorial papers in niche journals to introduce the field to Bayesian methods. So I'd like you to talk more about that because that seems super interesting to me.
So I have definitely done that in linguistics. So I've published a paper with Ladislas, a colleague of mine. He has been also working in linguistics. Some of the tutorial papers I've written, for instance, about ordinary regression models were targeted at psychologists because this is where I'm from, so I kind of understand a lot of stuff there. But all the other kind of papers in other fields were basically people who had been using BRMS and were interested in writing a tutorial or something like that. and then asked me if I wanted to participate in their papers because I was the author of BRMS, and I was, of course, kind of happy to do so. So I happen to, for instance, have this tutorial in Linguistics journal with like some specific applications in linguistics. A lot of other stuff is then psychologically related, but I know there are also like other BRMS tutorials or blog posts or whatever, not necessarily written or co-authored by me in other fields.
Well, definitely worth it. I don't know if you were wondering yourself that, but it seems to be really, really worth it because it does introduce people to this new method. And like it seems many people have picked up BRMS in particular and Bayesian methods in general, thanks to these tutorial articles. And I really love this idea. I mean, it's really great. And so also something I'm wondering about, and that's related to the PhD incentives we were mentioning before, I'm wondering is you have advice for people realizing that Bayesian methods would be useful to their research, but who face challenges from advisor or reviewers?
Yeah. So
that's a tough question.
Yeah, no, it's a tough question. And so I answer that from the background of my experience with that, which is in applications, mostly psychology related, but has some other fields. So this may not generalize. So first of all, I know there is lots of expected pushback from reviewers, which then doesn't happen. So it's basically people are like afraid of, or supervisors are afraid of kind of using Bayesian methods because then they have heard like some prior something subjective, and so they're suggesting their PhD students not to do it. And then when we do it, like for instance, together with me, and we kind of explain what we have done and why we have done that, I've actually rarely, if ever, got any pushback from reviewers, but it may be very specific to the fields. And I think it's also because fields have been shifting. So if you have people who have been doing that for quite a long time, when they were younger in their career, that kind of Bayesian statistics was not a thing in applied work, they may be more hesitant or more reserved against it. But like all the younger people, I think, are not. So in lots of ways, it's kind of people are afraid of reviewers not liking Bayesian statistics, but I've like rarely actually seen that. Yeah, with regard to supervisors, it's a little bit harder, right? Because then, of course, I can kind of convince PhD students, or I can tell PhD students the arguments, then they can go to the supervisor and explain. But of course, it makes it easier, for instance, if kind of I can talk to the people and can then directly address what they are worried about. For instance, they've been thinking like about subjectiveness of priors or something, and I can kind of explain how kind of all modeling is subjective in lots of sense, and we need to kind of justify all our model in the first place. And then, of course, we are not saying this is great, but in lots of cases we're using kind of very wide priors, which I don't like, but we have to start with some default, and then usually, unless the data is like really weird or the model is like really bad with respect to the data, the prior doesn't add much or it doesn't influence much. Although in lots of cases we actually have prior knowledge which we should use but then don't because people are reserved about that. So I think it's mostly about kind of talking to people directly about their reservations and then trying to kind of resolve them, which is easier for me, of course, than for like PhD students.
Yeah, of course.
Not really an advice. Or basically, if we want to turn that into advice, if someone faces issues like, I hope that doesn't happen too often, like people write me an email and I'm going to talk to your supervisor. No, I mean, probably a little bit weird, but I have done that and it has helped.
Yeah, for what it's worth, I think it is definitely something useful because oftentimes I'm guessing that these are always the same reservations or counter-arguments that people face, so especially about the priors. And I have two thoughts about that usually, and we'll talk more about that at the end of the show, actually, when talking about your current research project. So let's finish up on BRMS first, and well, I hope this advice will be useful to people facing this difficulty. And then I want to ask you, because we talked a lot about BRMS's strengths. So now I want to ask you about its main weaknesses. What do you think they are, in your opinion? And also, if you were to do it all over again, are there some parts of the library that you would do differently?
Yeah, so what's the weaknesses? So I think I've worked a lot to remove a lot of the weaknesses in the sense that because BRMS has so many features, you also have to support a lot of combinations of features. And there have been times where lots of stuff that was working for some models but not for others. So there, and if we speak of a feature matrix, and then off diagonal is basically combinations of features which are allowed. BRMS wasn't always that dense, so there were lots of like empty spaces where things couldn't be combined. I think this was one weakness because people wanted to combine it and couldn't, so I've worked hard on actually closing it. I'm not really sure if I want to call it a weakness or not, but of course, BRMS makes it very easy to fit quite complex models, which are easily on top of the head of people doing it, and also on top of my own head. So it's kind of when people like start, not simple, and then gradually build up their model, but like fit a really complex model right away. And I'm doing that all the time, and then I'm regretting it. And then, of course, sometimes like the results are hard to interpret, or the model doesn't converge, or the model just suddenly takes days to compute because it actually turns out to be a complicated model on lots of data. And so I think one of the weaknesses of these kind of powerful but easy to use front ends is that we kind of have to restrain ourselves from going too complex too quickly, because even if we can fit it and something comes out, it doesn't mean it makes a lot of sense necessarily. So I think slowing down the model building is something that generally helps. And of course, it's easier if you have to write your stand code yourself and debug it. But I'm not sure if that's a weakness, but it's definitely something that I need to be careful about it all the time. And I assume it happens to other people as well. So right now, I'm quite happy with the status of BRMS. There are some features that I want to add, but the general structure is good in place, I think. I mean, one weakness is, but it's kind of shared by most STAN-related stuff, is that it needs a compiler. We have been becoming better in the last couple of years to get people used to compilers, but whenever, for instance, Apple releases a new version of macOS and they change something in their own compiler, they're breaking their own toolchain or our toolchain, and then we got stuck, or we recently had issues with Windows and with newer Stan versions. So I think this is one of the weaknesses. I think it's also a weakness of Stan that we need to make it easier to use and make it more fail-safe combination with compilers. So if there are things I would like to do differently, not anymore. So there have been multiple times where I had seen I'd made huge mistakes in the development. For instance, the first time I implemented multivariate modes, that is with multiple response variables, I did it fundamentally, I wouldn't say wrong, but I developed fundamentally like dead end direction. And then I kind of just had to remove and deprecate and then remove the whole part and start all over again. So everything I wasn't happy about, I already in multiple weeks of work removed and redone. So nowadays, I think most of the structure is good. There are some like minor things that I want to change, which I'm going to do in BRMS 3, which will happen 2021 at some point, whenever I've like a little bit more time, that I'm going to change the last things I'm unhappy about.
That means 2021 will already be a better year than 2020.
Yeah, I mean, I promised all these stuff in 2020, but then it didn't happen. So don't count on me too much.
Yeah, but maybe that's a good thing. I think we should just forget about 2020 entirely.
I wouldn't be opposed to that.
Yeah, PSG almost win the Champions League. So, I mean, in that case, I wouldn't have been forgetting about 2020. But now, I don't care anymore. It's like...
I understand.
That's great. That's good to hear that you feel good about where the package is now. And I definitely relate to the compiler stuff. We have the same problem in PyMC and in Windows. And for multiprocessing, it's like you have these kind of problems. Like for Windows, for macOS, there was a problem with Python 3.8 and the new macOS. Plus, it's like, combinations of stuff. It's like the new version of Python, which breaks on new macOS, and you're like, okay, I'm a statistician.
I totally agree. I'm just happy we have people like Ben Goodrich in the Stan team, who is kind of just eager and able to figure that out. Because sometimes I see an error, someone posts an error, I have literally no idea what it means. And then we have people like Ben who then see, oh yes, this is that, and kind of solves it. So this is definitely not something I'm quite good at.
Yeah. Well, it's the same for me. And then we have also people like that on the PyMC team. Like, I'm thinking on the top of my head, it's like Adrian is able, he's really good at that. Brendan Willard, Chunpeng Lao also. I'm really glad they are here.
I fully understand.
Yeah. Okay, last question about BRMS. Mm-hmm. Do you have some new features and improvements in store that you're working on for future versions?
Yeah, so one thing I want to add kind of after I basically got funding and then kind of did all the related STAN things, prototyping and simulation studies, is kind of latent variable modeling, which is something relevant in psychology, social sciences, where your variable is measured by multiple like observed indicators, but you don't model the observed indicators directly, but you assume that there's some latent variable behind it. For instance, how outgoing you are, and then you could ask people different questions of how outgoing they are in different ways, and then you could combine that into like one indicator, then the latent variable, kind of how outgoing, and then you can continue modeling that. And this is kind of stuff that relates to multi-level models, but in a way that latent variables, in the way I envision that using some structural equation modeling, which is kind of the specific term, would mean that we can use latent variable both as responses and as predictors in kind of multivariate models. And this is something I want to develop BRMS further, but there are lots of difficulties along the road to kind of adding complex enough structural equation models, writing them in Stan, checking their calibration, optimizing them so that they run fast, don't have too much convergence problems, because those are really hard to fit. And once all of this is done, and I hope I get some funding for that eventually, then this is going to be a feature in BRMS, which is kind of one of the things I hope I'll do in BRMS 3.
Nice.
But there are lots of minor things like adding new response distributions, adding new autocorrelation structures, lots of things, but it's mostly kind of improving on what is already there and making it even more.
Yeah. That's super good to hear. So if listeners want to come and contribute to the GitHub repo, well, the link will be in the show notes, folks.
Yeah,
so
please, I would be very happy.
feel free to go there. Okay, let's talk more about one of your big current projects right now that you mentioned at the beginning of the show, which is a software-assisted Bayesian workflow. And so you were talking about better or more intuitive or easier choice for priors. So let's go back to that, because it's a can of worms. I mean, we could do a whole episode about prior choice.
Sure, yes. So I think there are different aspects of prior specification. The first one is that we actually understand what we want to do with priors and how we achieve that. So what kind of prior structure we specifying. And I'm writing slowly, but it's on my to-do list on a paper that basically discusses principles of specifying prior distribution. So how shall we choose priors? According to which principle shall we choose that in some general purpose manner? So to give people guidance, because in lots of cases, people have asked me, I'm like, yeah, I have literally no idea without understanding your specific model and data and theory, which remains true. But of course, there are some underlying principles I and other people presumably are kind of using to come up with some good recommendations for that, and I just want to write that up. So that's one aspect of that. The other aspect is that it's when we're specifying priors independently for each parameter or for each term in a regression model, for example, as soon as we add more and more priors, more and more terms, the joint prior basically over all these terms becomes kind of infinitely bad. In the sense, if we have a regression model with, let's say, 15 predictors, and each of them has some like normal distribution that is like reasonably not too wide, then in the linear regression model, the percentage of explained variance R squared, the deterministic factor, basically is almost 1. Like the prior based on the regression coefficients with very wide prior on R squared, the implied one is like almost 1. So even if our priors in each individual terms is reasonable, combining them leads the model a priori to assume that we can explain almost 100% of the variance, which in real data almost never happens. In other words, the prior strongly suggests overfitting. And basically what it leads us to the understanding is that we need to develop joint priors over different parameters, over different terms, and can kind of combine all the priors into like one bigger one that we then can kind of, whose complexity we can control jointly using just a few hyperparameters. And if we develop those kind of priors, and this is parts of what I'm like doing and writing grant proposals for, is kind of developing those priors, for instance, for like some more complex multi-level regression models, and then the user just has to specify a few hyperparameters. For instance, how big do they expect their R squared to be? For instance, they expect 30% of explained variance with some uncertainty. They can specify that. And then this kind of prior translates to the regression coefficients and prevents a priori overfitting. So it's basically developing joint priors is, I think, one of the big topics of actually making priors feasible for complex models. Because in lots of cases where we see examples for like informative priors, it's like overly simplistic models that we will not or rarely use in practice. So the complex models we fit in practice require complex prior structures, and we don't really have them, or we only have them after a lot of work for each individual project in cooperation with some statisticians. And I think improving on that and helping people specify their own priors reasonably well and developing like reasonably joint priors, I think one of the biggest topics in prior specification, at least from the applied perspective. And this is something I want to contribute on more in the next couple of years.
Yeah. I mean, this sounds really fascinating and super helpful for practitioners. Yeah, as you say, for instance, in hierarchical models with complex T-code functions, or if you have a link function, even that, it complicates everything in the choice of priors. And yeah, also sometimes it's useful and easy to think of the prior as relating to a variable of scientific interest.
Yes.
So it's good. In that case, you're quite lucky because you can think of your prior as that, and then you can do prior predictive checks and see what this means on the outcome space. But often in hierarchical models, often hyperpriors won't have a real scientific meaning. And so it will be super hard to choose them, even with prior predictive checks.
I agree. And so that's another aspect which we're trying to do, is that we kind of ask the users and the experts for advice on kind of scales that they understand, for instance, the outcome scale. So they usually understand the response areas quite well. And based on the expert knowledge they provide on the outcome scale, we are transforming that to some joint priors on the latent parameter space, right? So ask experts and people about stuff they understand well, and then transform it in some principled manner to something they don't, and we also don't understand well necessarily. But if it's reasonable on the outcome scale and then transformed back, we have the hope that it's also a reasonable prior on the latent scale. And if it's not, we have to ask ourselves if our prior information is something reasonable, or if we had made another kind of mistake, so like have other problems in our kind of modeling workflow.
I see. Yeah, plus this idea of specifying the joint prior, well, the prior on the joint distribution is useful. So to me, especially if you can relate that to how much regularization that provides.
Exactly, yes.
Because often, like one of the universal usefulness of priors in the Bayesian framework is that it provides for free regularization and protection against overfitting.
Yes.
But it's like the theory. But in practice, understanding how using a certain type of prior, like a more informative prior, translates into a more regularization and less overfitting, I think that's quite hard to really understand.
Yes, it's very hard, especially if we have independent priors, because then things blow up if we have lots of parameters. This is exactly the problem we are facing, and we need to basically be better in this.
Yeah, but I mean, that's also why the project is interesting, but it's true that it's clearly something that needs further improvements, because I'm like, even when I'm working like on electoral forecasting model, for instance, I'm using a multinomial regression. And so you have the multinomial likelihood, then you have the softmax link, then you have all your latent parameters. And often I'm using a multivariate normal to relate the coefficients, so the slope and the intercepts, and all that has a hierarchical structure. And so at the end, I'm like, no, I have a kind of intuition on which priors are good or not. But this is a huge interaction machine. And so you're like, okay, does this prior make sense? And am I regularizing too much or not? And yeah, you don't really have a really good indicator of, okay, this is good. This means that I'm trying to regularize by that much. So this will be super useful.
Yeah, I agree. And I think another aspect of this is that we add prior sensitivity methods, that basically we fit a model and then check how sensitive the results are with respect to perturbations in the prior distributions. Because like, even if we didn't give the prior much thought, but then the results don't really change with respect to some certain kind of perturbations of the prior, then at least our prior in the range where we specified it wasn't super informative, which sometimes is desirable, sometimes is not. But I think it comes down to lots of aspects around prior specification, but also prior sensitivity analysis, that we are actually having projects also with Aki, and specifically with Noah, one of the PhD students of Aki. We're kind of working on better prior sensitivity methods and sensitivity checks.
Yeah, definitely. This is clearly related. And so what would it look like? I mean, ideally, what do you folks have in mind? What do you want the output of this research to be?
Of the prior sensitivity checks, you mean?
Yeah, sensitivity checks, also the regularization quantification. Like, what would you like these to look like to help practitioners at most?
Yeah. So it's basically that we have some certain outcomes which people understand, for instance, changes in posterior distributions when perturbing the prior, for example, in posterior mean, posterior standard deviation quantiles, but also some more like general purpose method, like if we have some divergence measures or like difference measures between distributions that we see basically graphically, if we change the priors in a certain way, how much does the posterior change and what aspects to change? And of course, related to that, how would decisions change? So if people are making certain decisions based on the results, is one question one could ask is basically, how much do I have to change the prior to change my decision?
Yeah.
If the amount of prior change necessary to change the decision is absurd, then at least it kind of I have some idea about robustness against some assumptions I may put into my model. This idea, like how much do I have to change something that has been like done in classical statistics for decades. For instance, in meta-analysis, there is something called Rosenthal's fail-safe N, which is basically how many studies with a null effect do I have to add to a meta-analysis until the average effect is no longer significantly different from zero. There are lots of aspects of that which I don't agree with, like significantly different from zero, but the general idea is how much do I have to perturb my inference to come up with different conclusions? And I think this is one quite good way of like thinking of changes in models or in priors or in data, of how robust in whatever way are my results to my assumption.
Mm-hmm.
And I think if we do that in a graphical manner, specifically and efficiently without having to refit the model every time we change the prior, this would be a really nice addition. And this is what we envision it to look like.
Mm-hmm. Yeah, agreed. I subscribe to this vision. I love it. And when you're talking about the software-assisted Bayesian workflow, so like this elicitation of prior knowledge and so on, how do you envision it? Could it be like, I don't know, something like on the command line or stuff that prompts the person on the computer and then asks them the same questions for each type of analysis?
Yeah, I mean, we can think of that in some sense like this, but it's not necessarily kind of prompting answers. The idea is basically when we speak of a machine-assisted Bayesian workflow, it's that the machine kind of replaces the statistician. Mm-hmm. In the sense that the user can ask kind of, okay, recommend me next steps. What are the next steps? And the machine can say, okay, look, I see that in your workflow, you've started building the following kind of model. How about expanding that? For instance, you could add some more terms. This is some example. Here are some case studies you could look at if you're interested more. Or, for example, the machine basically tells, I see in the posterior predictive checks that there's some certain kind of misfit. I also know that your data is count data because you have specified your response to be counts. And I see kind of over dispersion in posterior predictive checks, why not instead of Poisson use a negative binomial? Mm-hmm. So it's basically what a statistician would do when working with people on their analysis. I think a lot of which can be encoded into a machine and then basically helping the user as they go through the Bayesian workflow. Of course, this requires lots of work on the Bayesian workflow itself. And we have recently on Archive, like 2 days ago, published like a 77-page long manifest about Bayesian workflow. It's called just Bayesian workflow. There's lots of people on it.
Yeah, I saw it.
Basically, so that's some aspect of the statistical theory, but it's more like an overlook, and there are lots of areas of the Bayesian workflow statistical-wise where we have to do method development. And then, of course, we have to put that up into software and then kind of build this machine assistant workflow around it. I have a prototype of that and talked about that a little, but it's hard to do that, and we need lots of stuff beforehand before we can actually like reliably teach a machine to do that. But one of the PhD positions I will have in Stuttgart will be basically about certain aspects of automating Bayesian model building.
Okay. Yeah, okay. That makes sense now.
And by the way, I'm also like, I will be looking for PhD students soon. So whoever sees this and is interested in working with me on Bayesian workflow aspects, like you can already write me an email, and as soon as kind of the job application is kind of prepared, then I'm going to inform you about that.
Of course, that's really great. And it will be with you in Stuttgart, right?
Yes.
Perfect. So, listeners, if you're interested, yeah, okay. This sounds really amazing. I would love that. It's like having a computer version of Aki with you when you're modeling, basically, you know.
Yes, exactly. Yes. We thought of like if we are bored at some point, we could add different styles, like Andrew Gellman's style or Aki Vectori style or Michael Betancourt's style. There could also be a Paul Bürkner style in Bayesian modeling. So we are the top choices.
No, definitely. That's definitely super awesome, because I also think that it would basically supercharge the workflow indeed, like in the sense that it would help the human factor where it's not really good, which is like retaining in our brain a huge amount of information and like retrieving it exactly at the moment we need it, you know, because I'm guessing a lot of people know, oh yeah, when you have over dispersion in the data, you should look at a negative binomial instead of the Poisson, but they don't think about it when they need it. It's like having the computer do that because they're really good at remembering things and retrieving them when it is useful. That's really great, because then you can let the statistician focus on what she knows best, you know?
Yes, I very much agree. Yes.
Yeah. That's amazing. Really love it. Yeah, so I think time is flying by. So yeah, we should think about wrapping up here. But again, I want to say that these workflow projects look so promising and I can't wait to see this happening. And as you said, you folks already have a paper about that a few days ago with a lot of people on it. It's already on my reading list, but my reading list keeps growing. So I don't know if it's a good sign, but definitely gonna read that. It looks super interesting. And I'm of course gonna put it in the show notes for people. Last question before we close up the show. Well, before the last question, but yeah, you talked a bit about that already, but I'm wondering more generally, what does the future of probabilistic programming languages look like to you and which advances are particularly exciting to you?
I think one main problem we right now have with all probabilistic programming languages and like Bayesian estimation more generally is that when we want to do it accurately, it's slow. So when we do it like with full MC-MC sampling, it's very fast as compared to a few years ago, but it's still very slow if we have really big data and really complex models. If we kind of step away from those algorithms with asymptotic guarantees like MC-MC has in certain situations, and for instance go for like variational inference, which is faster, but then potentially in some sense infinitely bad in estimation, at least we don't have strong theoretical guarantees, for instance, with respect to how accurate the posterior is, and if we care about interpretation of parameters, we need that. So I think it's kind of making it accurate and efficient at the same time. Obviously, is kind of always a problem, but it's, I think, specifically a problem in Bayesian statistics, because with really big data and really complex models, this becomes prohibitive for our Bayesian workflow. In the Bayesian workflow, we don't just fit one model. We fit a lot of models for like different reasons. And we iteratively build our models. And so we're fitting a lot of models, a lot of which will end up being like kind of bad in retrospect, but we didn't know before. And so we need to make inference faster and diagnostics faster so that we can actually go through the Bayesian workflow and do that without kind of having to wait months for all of our models to fit. So I think efficiency in the languages, in the algorithms, in kind of usage of more cores, for instance, within chain parallelization is one of the biggest developments. And then, of course, the other one is kind of dissemination for more people, because not everybody is fortunate enough to be able to have a statistician, Bayesian or otherwise, kind of sitting next to them, helping them with their analysis. We just don't have enough statisticians to do that. And I think this kind of machine-assisted idea that we have some ideas of the workflow, we have that built into machines that can help users. I think those will be some big steps forward in kind of improving the quality of statistical inference in general, kind of across all the quantitative science.
Yeah, definitely. Couldn't agree more. And yeah, that's why I'm very passionate about these kind of projects, because I think it's something that also resonates with me and that I often see, for instance, on the PyMC discourse, So yeah, definitely something that would be really awesome and great project to work on. Okay, Paul, I think we can call it a show, although we will have a lot more to talk about, but before letting you go, though, I have to ask you the two questions I ask every guest at the end of the show. So the first one is, if you had unlimited time and resources, which problem would you try to solve?
Yeah. So this is kind of repetitive, so I'm making sure. It's basically developing the Bayesian workflow further. And I mean, we have lots of people working on it, and we're trying to get lots of money from very different sources for that. And I think we'll always need more people and more money and more time to work on that, because this is becoming really great. We just have to continue working. So that's basically how I would spend infinite money, time, and people on it.
Well, that's funny. I love it. It's like I had Lauren Kennedy on the previous episode, and she gave an answer like that too. Like I think if I remember correctly, she says something like, I would do a huge global study so that then we can apply MRP on it and learn more about what people think. And it's just like, really, that's good. It shows that you're passionate about what you folks are doing.
Yes, I am.
Okay, and second question is, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
One person I would like to talk to, like at dinner or otherwise, is kind of Terence Tao. He's kind of one of the most famous mathematicians these days. And what I find so impressive about him is that he has made contributions in so many, at least for me, very different fields of mathematics. And so I think just hearing from him his story and basically how he thinks of math would be like really inspiring, because I mean, I've studied mathematics, but I have not kind of dived into kind of the really mathematical direction. So I've done some proofs, but it's not so much. And I think it's very interesting to kind of hear from him how he thinks about mathematics and what could we do, for instance, to apply what he has learned in all of these different fields in practice, and how to, for instance, improve our algorithms to make the most of mathematics for all of our applied problems. And I think it would be quite inspiring to talk with him about math in general.
Yeah, definitely. Unfortunately, I don't think he listens to this podcast, but hey, you never know.
Probably not.
But maybe one of his friends. So we'll see, hopefully. Okay, well, Paul, thank you very much. It was so great learning about BRMS, about the state of Bayesian methods in social science in general. And I'm sure many listeners are going to try it out now. And well, I think I speak for everyone when I thank you for the wonderful work you and the whole STAN team do for open source and open science and for software-assisted patient workflow in particular. As usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Paul, for taking the time and being on this show.
Thank you, Alex, for inviting me. It has been a pleasure to talk to you about these projects.
Well, thanks.
And I'm looking forward to listening more of your podcast with other people.
You're always welcome.
Yeah.
Yeah, come back on the show anytime.
I will happily do so. Thank you.
Great. This episode of the Learning Bayesian Statistics podcast was brought to you by Tidelift. Tidelift helps organizations effectively manage the open source behind modern applications, accelerate development, cut costs, and reduce risk with the Tidelift subscription, so you can create even more incredible software even faster. Learn more at tidelift.com. This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or on Podchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman with MC Lars and Megaram. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.